Hello, I'm Michael Bunch. I'm the plant pathologist at the North Dakota State University Carrington Research Extension Center. I'd like to take this moment to share what we have learned in about a decade and a half of testing relative to the efficacy of the fungicide PROPULSE versus competitive standards for the management of white mold in dry beans. This testing was conducted in most studies on pinto beans, sometimes in kidney beans. Row spacing was 14 inches. Seeding rate was 90,000 viable seeds an acre in most studies, sometimes 80,000 viable seeds an acre. Fungicides were applied with a handheld spray boom, pressurized by carbon dioxide, and applied in 15 gallons an acre spray volume. Fungicide droplet size was fine or medium in studies conducted from 2010 to 2021, and then calibrated relative to canopy characteristics from 2022 to 2024. We conducted testing with 2 sequential fungicide applications, with the first application at early bloom and initial pin pod, and the second application 7 to 14 days later, depending on the study. Testing was conducted with 5 or 6 experimental replicates in almost all studies. White mold was assessed by evaluating every plant individually for the percent of plant impacted by white mold in a minimum of half of the plot. This assessment was conducted at or near dry bean maturity. We harvested these dry beans by simulating knifing. We clipped the plants at the base, we windrowed them to dry, and then manually lifted them into the combine. We did this rather than straight harvest because we wanted to make sure that differences in the standability in the dry beans across the footprint of the study did not add noise into our yield data, did not bias our yield results. Supplemental irrigation was applied as needed to establish the white mold disease pressure needed to evaluate fungicide performance. I'm going to start off by discussing fungicides and fungicide application rates that can be applied twice in season and stay on label. We conducted testing with the same fungicide applied twice sequentially, not because we're recommending that, but because that's the best way to rigorously assess comparative efficacy. By assessing the same product applied twice sequentially, we are compounding any differences in efficacy between those treatments, because you get the additive effect of the differences in efficacy. So we conducted testing with 2 sequential applications of the same fungicide, and we did this to help inform comparative efficacy, whether you're making a single application as a standalone application and you need to figure out what product would work best for your situation for a single application, or whether you are applying, you're looking to select a fungicide that can be applied in rotation with another fungicide, or if you're looking to apply the same fungicide twice. But really, for all 3 of those scenarios, these research results are intended to guide decision making. Let's start off with PROPULSE at the high rate of 10.3 fluid ounces versus the low rate of 8.6 fluid ounces. Well, you can see in combined analysis across 8 studies that there is a slight difference in the efficacy. As you increase the application rate, we saw a trend towards slightly better disease control and slightly higher yields. There was no statistical separation between the fungicide treatments, but the trend was consistent between disease management and yield. Let's look at PROPULSE at the high rate versus Topsin at 30 fluid ounces. What you can see is that in this case, we had slightly inconsistent results relative to disease and yield, no statistical separation for either, but trends in the opposite direction. Ultimately, we had slightly higher yields with PROPULSE versus Topsin and slightly lower disease with Topsin versus PROPULSE. This indicates that there's a certain degree of noise across the studies. I would suggest that you look at the individual results across individual studies in the detailed testing results that I have posted accompanying this as a standalone PDF. But these results indicate that these 2 fungicides are very similar in efficacy. Now looking at Topsin at 30 fluid ounces versus PROPULSE at 8.6 fluid ounces, now you see consistent results where the Topsin is performing better than the PROPULSE. No statistical separation, but very consistent trends. What about PROPULSE at 10.3 fluid ounces versus Endura at 8 ounces? What you see is that the Endura 8 ounces is showing a slight trend towards improved white mold management versus PROPULSE, but the difference is not statistically significant. What about Endura at 8 versus PROPULSE at 8.6? Now you see that difference has widened. We still do not have statistical separation, but the Endura has a much stronger trend towards better white mold management versus PROPULSE. What about PROPULSE at 10.3 fluid ounces versus Omega? The Omega at 13.6 fluid ounces, we did not see a statistical separation between these two fungicides, but the Omega at 13.6 fluid ounces performed better than the PROPULSE. Omega at 13.6 fluid ounces performed even better than PROPULSE at 8.6 fluid ounces. No surprise there because of the rate response. And there we actually have statistical separation for disease control and a very, very strong trend, even if it's not statistically significant on the yield, that corresponds to the difference in the disease management. The efficacy Omega dropped sharply when you drop the application rate. And here you can see that 8 fluid ounces of Omega performed virtually identical to Endura 8 ounces, Topsin at 30 fluid ounces, and in this case did show a trend towards slightly better disease control versus PROPULSE at 10.3, but again that's a trend that's not statistically significant. The big take home here is that the Omega shows a rate response and you should not expect it to perform sharply better than competitor products if you apply the Omega at only 8 fluid ounces. What about applying PROPULSE alone versus with the copper-based product badge? I often get phone calls from people who are interested in adding a copper-based product targeting bacterial diseases, and they want to know how adding that product to their white mold fungicide will impact the efficacy of the white mold fungicide. What results from this limited testing suggests, and I would say limited testing is just 2 studies, is that adding the badge to the PROPULSE is definitely not deleterious to the PROPULSE. If anything, it helps a little bit with white mold management. What about Mirabis New at 13.7 fluid ounces? Our testing across 4 studies indicates that it is sharply less effective than PROPULSE at 10.3 fluid ounces. Likewise, Proline is much less effective than PROPULSE at 10.3 fluid ounces. Proline at 5.7 fluid ounces is also less effective than PROPULSE at 8.6 fluid ounces. And Quash at 2.5 ounces is less effective than PROPULSE at 10.3 fluid ounces. Finally, PROPULSE at 10.3 fluid ounces showed a trend towards improved disease management, white mold management, versus Roveral and Switch, which are 2 older fungicides that are rarely utilized for white mold management on dry beans, but they are registered. So that wraps up all the products that can, by label, be applied twice sequentially. Again, we developed those efficacy data with the goal of also informing a single application. Now I'd like to discuss Topsin or generic at 40 fluid ounces versus PROPULSE. So it used to be that every label for Topsin and generic Topsin indicated very clearly that 2 applications at 40 fluid ounces was prohibited. You could only make a single application at 40 fluid ounces of Topsin or generic, and if you were going to make 2 sequential applications, the maximum usage rate was 30 fluid ounces per application. A couple years ago, some of the labels changed, and they dropped the language explicitly prohibiting 2 applications at 40 fluid ounces, but they did maintain language recommending that if you're making a single application, that it be made at 30 to 40 fluid ounces, and if you're making 2 or more applications, that those applications be made at 20 to 30 fluid ounces. What's lacking in those labels is this explicit prohibition against making 2 applications at 40 fluid ounces. My interpretation of those labels and the way that they are structured is that the label still indicates that if you are making only a single application, the maximum usage, that you can make that usage rate up to 40 fluid ounces, but if you're making 2 applications, the maximum usage rate is 30 fluid ounces. If you decide that you want to apply Topsin twice at 40 fluid ounces, I would recommend you read the label carefully and you follow up with the manufacturer to make sure it's legal. My interpretation is that it is not. That said, I am now going to present data on the efficacy to 40 fluid ounces of Topsin. Just like our previous data, this is data where we applied Topsin twice at the same application rate, in this case 40 fluid ounces, and compared it to a competitive standard, in this case PROPULSE, also applied twice sequentially at the same application rate. The idea behind applying the same fungicide at the same application rate twice sequentially is that it compounds the differences in efficacy. It multiplies, it adds, you have the additive effects of whatever differences in efficacy, and you're better able to differentiate efficacy. In this case, I'm providing these data to inform decisions for selecting Topsin when you're planning to apply Topsin as a single application, either as a single application program to white mold and dry beans, or if you're planning to apply Topsin as a single application in rotation with another fungicide. Again, my interpretation of the label is that it's not legally permissible to apply twice at 40 fluid ounces. Here are the data. For Topsin twice at 40 fluid ounces, what we see is that there is a clear trend towards improved white mold management with Topsin at 40 fluid ounces versus PROPULSE at 10.3 fluid ounces. Thus, if you're going to make a single application of Topsin in the season, I would recommend applying at 40 fluid ounces. If you remember, the 30 fluid ounce rate was roughly comparable to PROPULSE at 10.3 fluid ounces. Here you see a very clear trend where it's performing better. It's not a surprise because we know there's a rate response as you go from 30 to 40 fluid ounces of Topsin, with the 40 fluid ounces performing better. So, if you're going to apply Topsin as a single application, I would recommend applying it at 40 fluid ounces. The testing that we did as a single application rotation with PROPULSE actually had the Topsin at a 30 fluid ounce rate. But again, if you're making a single application, I would recommend 40 fluid ounces. The cost is not very much more, and it clearly is more effective. So, should you apply the Topsin first when rotating with PROPULSE, or should you apply the PROPULSE first? We did not have statistical separation across these treatments, but we saw a very clear trend where applying the PROPULSE first gave us better white mold management than applying the Topsin first, at least when the Topsin was applied at 30 fluid ounces. Again, I would recommend applying the Topsin at 40. So, what have we learned? Let's give overall conclusions. If you're going to make 2 applications of the same fungicide per season, in order of approximate relative efficacy, the following 4 fungicides all work well against white mold. Omega at 13.6 fluid ounces, Endura at 8 ounces, PROPULSE at 10.3 fluid ounces, and Topsin at 30 fluid ounces. Reducing the rate of PROPULSE to 8.6 fluid ounces reduces disease management, white mold management, and reducing the rate of Omega below 13.6 fluid ounces also reduces the efficacy. Same with Endura. Okay, now if you're only going to make a single application this season, now you can apply the Topsin at 40 fluid ounces, and you can see that my relative ranking here shifts a little bit. Omega at 13.6 fluid ounces and Topsin 40 fluid ounces are the most effective products when applied a single time, and then Endura 8 ounces, PROPULSE at 10.3, and then finally Topsin at 30 fluid ounces. If you are planning to rotate Topsin or generic with PROPULSE, our research indicates that PROPULSE should be applied first and Topsin applied second. Our research also indicates that the following fungicides are less effective than PROPULSE applied at 10.3 fluid ounces. Proline, Quash, Miravis Neo at 13.6 fluid ounces, Proviral, and Switch. In closing, I'd like to give sincere thanks to my staff who contributed to this research: Aaron Faust, Joanne Collis, Jesse Hafner, Gabby Henson, my current staff, and Tommy Smiorini, Billy Kraft, and Michael Schaefer, my previous staff. The very hard work and long hours put in by these staff has made this research possible. I'd also like to give sincere thanks to Scott Halley, who contributed towards this research effort when he was the plant pathologist in Langdon. He's now retired. And Amanda Ahrens, the research specialist who worked with him at that time and continues to work as a research specialist in Langdon to this day. I'd like to give sincere thanks to North Harvest Bean Growers Association, the North Dakota Crop Protection Product Harmonization Registration Board, administered by the North Dakota Department of Agriculture, and the private companies who funded this research. I'd also like to give sincere thanks to Bollingburg Seeds, Green Valley Bean Company, and Kelly Bean Company in Hatton for donating this seed for use in this research. We give very sincere thanks to these companies and these organizations that made this research possible. In closing, thank you for your time and attention. I hope these research results help inform your operation and help improve the profitability of your crops. Thank you.